In this video, I want to derive the conditions under which an AR1 process is stationary in variance. So remembering again what our AR1 process is, we have that xt is equal to rho times xt minus 1 plus some error et, where again we have that this et is iid with a mean of 0 and a variance of sigma squared. So let's derive the conditions under which our process xt is constant in variance. So let's first of all take the variance of both sides. So we have that the variance of xt has got to be equal to rho squared times the variance of xt minus 1 plus the variance of et. And the reason that we've got a rho squared here rather than just a rho is because the variance of some constant a times a random variable x is equal to a squared times the variance of x. That's a property for the variance operator. Okay, so now we want the conditions under which we have that the variance of xt is equal to the variance of xt minus 1. So if we actually substitute this into the above expression, so explicitly we're going to substitute in for the variance of xt minus 1 here, we're going to have that the variance of xt is equal to rho squared times the variance of xt plus, well, we know what the variance of et is, it's just sigma squared, so we just get a sigma squared over here. And then if I take this term here over to the left-hand side, I have that 1 minus rho squared times the variance of xt is equal to sigma squared. So we have finally that the variance of xt is equal to sigma squared divided by 1 minus rho squared. So that is the variance of our process if it is variance stationary. And this actually turns out some of the conditions which we require on rho, because notice that we have to have that the modulus of rho is less than 1, because if it was equal to 1, the variance would actually be infinite. So because the bottom here would actually be 0, so we'd have sigma squared divided by 0, which would be infinite. And actually, even though we didn't state it, it is a requirement for a stationary time series to have a finite variance. So if it has an infinite variance, then it is no longer stationary. And note that if rho is greater than 1, the denominator now would be less than 0. So the variance would be negative. And that doesn't have any real meaning. So we have to have that the modulus of rho is less than 1. So that's our second condition for a process to be stationary, or for our AR1 process to be stationary rather. In the next video, I'm going to derive the conditions under which our AR1 process has a stationary covariant structure. I'll see you then.